First example, let's see if you see what I see. Let's see, on the left, on the starting material, we got 2 carbons, right? On the right, the product, we got 3 carbon, and the functional group move 1 carbon to the right. Okay, all right, you have to think about how to do this. So we're making carboxylic acid. Well, how many ways you can make carboxylic acid? Well, you probably think about like carbon dioxide with the Grignard reagent, or you can use a cyanyl group, the sodium cyanide. Okay, all right, do retrosynthesis. So if you want to go with the Grignard reagent and carbon dioxide route, so you're gonna get this. You're gonna come from this. Synthetic equivalent of this carbon ion is ethyl magnesium bromide, and then react with carbon dioxide. Okay. How now? The question is, how would you make this carboxylic acid to the Grignard reagent, 2 carbon? Okay, just focus on 2 carbon. Think about this. To make this, you need the bromine on this position. Can you make bromine on that position? Remove the oxygen and hydrogen. Just bromine right there. Well, this is what you do. Okay. All right. We take the carboxylic acid, reduce all the way down to an alcohol. Lithium aluminum hydride, don't forget to quench. Okay, all the way down to alcohol. Now you can add a leaving group into it, bromine and chlorine. This is up to you. HBr, PBr3. Why did you give you bromine? Thionyl chloride, right? HCl and zinc and chloride. That one give you chlorine. There's a bunch of them you can do. Okay. Anyway, so my point is, you can make a Grignard reagent from here. React with carbon dioxide, adding an acid. There we go. That's the product. Okay. All right. If you're not really sure about how to use Grignard reagent, maybe you're more familiar with using cyanyl group. Okay, so sodium cyanide. Of course you can. Once you get to this point, when you have a good leaving group on its 2 carbon, add a sodium cyanide. Okay, you're gonna get sodium cyanide, cyanyl group on here, and then you do a hydrolysis. Then same product. Okay. All right. One more example. Let's take a look at this example. F. Let's see what we have here. So an ester to an alcohol reduction for sure. What this whole thing leaves, right? The carbon, the functional group stay on this carbon. The functional group stay on this carbon. So we're gonna keep this oxygen, right? Remove this guy somehow. All right. So functional group stay on the same carbon. Looks like we have to add a methyl group somehow. So gonna be something like this. This is gonna happen. Okay. Can you add a methyl like Grignard directly? No, you can't. We have an ester. Okay. If you add a Grignard right away, ester, the Grignard will attack one time. You get a ketone, and ketone is reactive still toward Grignard reagent. Second alkyl group attack, you get 2 alkyl groups on it. So no, you cannot use Grignard reagent. Okay, but we need this methyl to attack. All right. Well, this guy can attack. Maybe an aldehyde react with the Grignard reagent once. Okay. All right. So if you have an aldehyde react with Grignard, you're gonna get the product. But now the problem is, can you convert an ester to an aldehyde? Of course you can. That's one step. Our heroes, dibol. Okay. Take an ester, add dibol, quench, you get an aldehyde. For an aldehyde, bam, the product right there. Okay. You can do another way too. Maybe you're not familiar with this. Maybe you think about the Gilman's reagent. Okay, Gilman's reagent will require you to convert this to an acid chloride, and of course you can convert this, do hydrolysis to carboxylic acid first. Once you get carboxylic acid, you can make an acid chloride. You add Gilman reagent, you're gonna get a ketone, and then you do reduction to an alcohol. That also works. That's another way. Okay, there's a bunch of answers you can do this. Okay. All right. So that's an F. I think we got one more. Here we go. Oh, look at that. What we have here. Let's see. Okay, we have 5 carbon on the product. We have 1, 2, 3, 4, 5 carbon as well. Okay, so no adding carbon nor remove the carbon. Looks like we got to add 1 oxygen and open the ring. That's your task. Okay, let's count 1, 2, 3, 4, 5, 6. All right. It is used to be a ring, a 6-membered ring. Maybe something like this. Yeah, right. Maybe something like that. That could be. Look back to the reactant, to the starting material. How you get from starting material to this 6-membered ring. This is cyclic ester. Oh, that's one reaction. Do you know what that is? I do. Oh, I do. Okay, so let's do this. You can insert this oxygen to this cyclopentanone ring by doing this reaction. Remember that? Okay, we're gonna add MCPPA or peroxy acid. Basically, okay, rearrangement 1-2 shift. Okay, you get this guy. All right. From this guy, all right, I need to open the ring and leave an aldehyde. Can I use LAH? Nope, you cannot use LAH. LAH will open the ring and convert everyone to alcohol. Once you get alcohol, you have a problem. How would you selectively oxidize just one alcohol? That's quite difficult. The selectivity is not going to be great. Okay. Can you reduce but keep an aldehyde? Well, this is an ester, right? You can make an aldehyde directly from an ester. Our heroes, diebol. Here we go. Okay, use diebol. Diebol open the ring, but leave an aldehyde alone. This guy does not react with an aldehyde. So, ta-da! Look at that. Okay, so quite fun. Synthesis, huh? There's a bunch of ways you can do it, like a puzzle. Okay, our so we done with it. We got one more video. This one, how to make synthesize acetaminophen, and then you take this medicine. Okay, from phenol. Let's take a look.